So, hello friends. So, welcome to lecture series on nonlinear programming. So, in the last lecture we have seen that if we have a complicated network, how can we solve it using forward or backward recursion, but that is not a dynamic programming approach. Now, how can we solve the same problem, the same network which we have discussed in the last lecture using dynamic programming approach? Okay. You see that we have already find out the minimum path from node 1 to node 10 is 20 units, and the path is 1 to 2, 2 to 6, 6 to 9 and 9 to 10. This is the minimum path, and the minimum path length is 20 units. Now, how can we solve this problem into using dynamic programming approach? So, in dynamic programming we divide the larger problem into sub problems which we are calling as stages. So, we divide this problem into stages, we find out the solution of each stage and use the solution of the previous stage to the next stage till we get the last stage, and whatever we obtain in the last stage, that will give the optimal solution. Okay. So, how can we solve this problem? Let us see. In a dynamic programming we define some terms, some variables first. First variable is stage variable. Okay. We are calling this as stage 0 suppose, for which we are denoting by j. Stage variable we are denoting by j. So, these are the stage variables. The first stage we are calling as 0 stage. Okay. Now, this stage we are calling as stage 1, this stage we are calling as stage 2, and this stage we are calling as stage 3, and this is stage 4. Okay. Now, in this stage we are having only one variable because we are having only one node. So, we are calling that as state variables. Okay. So, here x0 is 1. What are xj's? What are xi's? Xi's are nothing but state variables. Okay. Now, in for this corresponding stage, how many nodes we are having? 3. So, we will be having 3 state variables corresponding to this stage. So, that is x1. So, x1 may be 1, 2 or 3. So, we are calling it 1, we are calling it as 2, and we are calling it as 3. Okay. This is stage 1, and then in this stage there are 3 nodes. So, we are calling each node as 1 x1. I mean x1 equal to 1 means this node, x1 equal to 2 means this node, x1 equal to 3 means this node. Now, for this particular stage x2 we are having only 2 nodes. So, 1 and 2. So, this is 1 and this is 2. For this stage we are again having 3 unknowns, I mean 3 nodes. So, we are calling it 1, 2, 3. So, it is 1, it is 2, it is 3, and this we are only having 1. Okay. So, first we are defining stage variables. Stage variables are 0, 1, 2, 3 and 4. Corresponding to each stage we are defining state variables. Here only one node, so we are calling x0 as 1. Here we are having 3 nodes, so x1 is 1, 2 or 3. It is 1 or 2, 1, 2 or 3, and then it is 1. So, it is 1. Okay. So, we have classified, we have distributed the entire network into stages and states. Okay. We have subdivided, you see this complicated network. This is a very simple example. This is an example how can we solve any complicated network using dynamic programming. We have divided this problem into some stages. Okay. And corresponding to each stage we define state variables. Okay. Suppose we are talking about x1 equal to 2, that means this node. Suppose we are talking about x3 equal to 3, that means this node. It is clear. Okay. Next we define certain terms. First is fj xj. what fj xj is? Minimum path from state xj in stage j to state x4 equal to 1 in stage j. Suppose you want f13, okay. f13 means f1 x1 equal to 3, okay, because it is it denotes this one denotes stage, okay, this one denotes stage, j equal to 1 stage, and 3 means x1 is 3, so x1 is 3, okay. So this means from this stage 1 and state variable 3, the minimum path from this to this is f13, okay. So what to find? We have to find basically f01. This is to find the minimum path from this 0th stage to x4 equal to 1. This to find out the minimum path length, okay. Now next we defined rj plus 1 xj plus 1. It is length of the arc from state xj in stage j to state xj plus 1 in stage j plus 1. Suppose r321, okay. Suppose we want to find r321. So r321 means, okay, j plus 1 is 3, that means j is 2. So that means x2 equal to 2 to x3 equals to 1. It is a arc length basically from x2 equal to 2, x2 equal to 2 is this, and x3 equal to 1 is this. So the arc length is 6 units, so it is equal to 6. Like dij what we having in the backward or forward recursion. In the same way here we defined like this rj plus 1 xj plus 1, okay. The arc length from xj to xj plus 1, xj in jth stage to xj plus 1 in j plus 1th stage, okay. Now how to find fj xj, okay. So suppose you want to find f13 like this. Now suppose you want to find f13. So f13 x1 equal to 3, that means this thing. So first you compute this length, that is r2 of x1 equal to 3 and x2 equal to 1 plus f of f2 of x2 equal to 1. You see this arc length plus this, the minimum what we are obtaining at this node to this node, okay. Then this 3, that is r2 x1 equal to 3 to x2 equal to 2 plus f2 when x2 equals to 2, the minimum of these two. The minimum of these two will simply give f1 x1 equal to 3. So in general how can I define fj xj? It will be minimum of rj plus 1 xj plus 1 plus f xj plus 1 xj plus 1. That will be the minimum of this will give fj xj, okay. Now let us find out the minimum distance. This is a certain terminology which we should define before starting dynamic approach. First we define stages. Stages means we define the entire problem into sub problems, as we already stated. The sub problems are stage j equal to 0, j equal to 1, j equal to 2, j equal to 3 and j equal to 4. In each stage we define state variables. The state variable here are 1, For this particular stage there are 3 unknowns 1, 2 and 3 because there are 3 nodes and similarly others. Then we defined Fj xj. Fj xj is nothing but the minimum distance from node xj in jth state to node x4 equal to 1 in 4th state, and rj plus 1 xj plus 1 is nothing but the arc length from xj in the jth stage to xj plus 1 in j plus 1th stage, is the arc length, okay. And the minimum of this, minimum over j will give fj xj. So, let us now find out the minimum distance from this to this, how we can start. First we will take stage 4. Again we are using a backward recursion because this stage 4 up to here it is stage 3, up to here it is stage 2, then stage 1 and then stage 0. Stage 0 will give the minimum from this to this, okay. So, first we find stage 4. For stage 4 it will be f4 x4, okay, f4 x4. Now from fj xj is the minimum distance from node I to node x4 equal to 1. So, from node x4 equal to 1 to itself the minimum distance is 0. So, it is 0, okay. Now, stage 3. Stage 3 means f3 x3, that will be minimum of r4 x3 x4 plus f4 x4, x4 equal to 1 of course, okay. Now, how can we make a table for this? Table is very simple for this. You see we are having x3 x4, okay. x3 are 1 2 3, here x4 is only 1, so x4 is only 1. From 1 to 1, when x3 is 1 x4 is 1, when x3 is 1 and x4 is 1, the arc length is 8. So, it is 8, that is r4 x3 x4, okay, r3 x4 x3 x4 8. Then 2 to 1, the length is 7 units, so it is 7. Then 3 to 1, when x3 is 3 it is 1, it is 9, so it is 9, okay. Now, r4 x3 x4 plus f4 x4, f4 x4 is 0, so add 0, it is 8 plus 0, 7 plus 0 and 9 plus 0, and it is f3 x3. Here there is only one term, so minimum is remain 8, minimum is 7, minimum is 9, and at which x3? This 8 is obtaining when x3 is 1, this 8 is obtaining, no, so it is x4, yeah, it is x3, it is 7 and it is 9. Oh, it is 2 and it is 3. Oh, sorry, it is x4, okay. It is 1 1 1. At x4 equal to 1 we are obtaining all the 3 minimums, 1 1 1, okay. So, this stage is over. Now, we go to stage 2. Stage 2 means f2 x2, which is minimum of r3 x2 x3 plus f2 x2 plus f3 x3, okay. Stage 2 means from here to here, okay. That means you vary these two nodes and find out the minimum from this stage to this stage, okay. So, it is, again you will make a table for this. you will make it x2 and x3. For x2 we are only having two values 1 and 2. For x3 we are having value 1, value 2 and value 3. 1 to 1, x2 1 to 1, it is 8, then 9, then 5. It is 8, 9 and 5. These are the arc lengths. Okay. Then it is 6, 7, 4. 6, 7, 4. Here it is 6, here it is 7, and here it is 4. These are what? These are R3, X2, X3. Now I want to add F3, X3 also. Okay. We want to add F3, X3 also. You see, F3, X3. F3, X3 are 8, 7 and 9. Okay. So it is 8, 7 and 9. It is 8, 7 and 9. Okay. First we write the value of the arc length. This is 8, 9, 5, 6, 9, 6, 7, 4. Value of arc length. And then we have to add F3, X3. F3, X3 from a previous table. From the previous table we have already obtained the minimum of this stage to this stage. Minimum of this stage to this stage we will add up to the arc length from this node to this stage. Okay. Now here the minimum is 8, 7, 9. So you add 8, 7, 9, 8, 7, 9. So what is the minimum? That will give F2, X2. Here it is 16, 16, 14. So minimum is 14. At which X3? You see, this 14 you are obtaining at X3 equal to 3. So X3 equal to 3. Now this 14, 14, 13. So it is minimum is 13. And this 13 we are obtaining when X3 equal to 3. So it is again at 3. Okay. So this is the second stage which we have obtained and shown a table also here in the PPT. Now similarly we will go for stage 1. Stage 1 will be nothing but F1 x1 as shown in the PPT, minimum of R2 x1 x2 plus F2 x2. We show here x1 x2 and then R2 which is the arc length from x1 to x2. Then we add F2 x2 which we already obtained in the last stage from the stage 2. F2 x2 we have already obtained, and then F1 x1. You see, now for x1 we are having 3 variables 1, 2 and 3. So it is 1, 2, 3, and x2 only having 2 values 1 and 2. So it is 1 and 2. Now 1 to 1, that is x1 1, x2 equal to 1. So the value is, the distance is x1 equal to 1 to x1 equal to 1, x1 equal to 1 to x2 equal to 1. There are one path, that is 3 units, and from this to this it is 2 units. So it is 3 and 2. Similarly, from x1 equal to 2 to x1 equal to 1 and 2 it is 4 and 5, then 2 and 3. And whatever we have obtained in the last stage, that is stage 2 F2 x2, which we already obtained here, it is 14 and 13. Okay, you simply add it here 14, 13, 14, 13, 14 and 13. Now for this x1 the minimum is obtaining at here, it is 15, and at x2 equal to 2. This we are obtaining as 18, 18 at both the values are 18. So it is obtaining an x2 equal to 1 or 2. Now here it is 16, here it is 16, and 16, 16 we are obtaining when x1 equal to 1 and 2 again, 1 and 2. Now the last and the final stage is stage 0. Stage 0 is f0 x0, which is minimum of this plus this. Here x0 is only one variable, x0 equal to 1, and x1 are 1, 2 and 3. So x1 is 1, 2 and 3. Lengths are 5, 7 and 6. So it is 5, 7 and 6 as shown in the picture also. And f1 x1 is the minimum path obtained, minimum value obtained in the stage 1, which is 15, 18 and 16. So you add 15, 18 and 16. Now the minimum of these 3 will give f0 x0, which you have to find out. So the minimum is 20 now, okay, and x1 equal to 1. So, x1 equal to 1, x1 equal to 1 means x1 equal to 1 means this one, this node. So, this to this, path is this to this, and it is obtained at 15, and 15 we are getting from this point, that is x2 equal to 2. You go now to know the minimum distance is 20, we are obtaining from here. What is the path? To know the path, we will go from the last stage to the first stage, backward direction. We go to the backward direction to find out the path. You see, it is 20 at x1 equal to 1. 20 we are obtaining from this point, 15. 15 we are getting from here. Okay, when x2 is 2, x2 is 2 means this one. That means this path. Okay. Now this 13 from we are getting, from where we are getting this 13 we are getting from here, okay, when x3 is 3. So x3 is 3, so x3 is 3, that means this one, okay, x3 is 3, this one, and the last one is, of course there is only one path, so x4 is 1, that means this thing. So this will give the path, the path also. So the minimum distance from node 1 to node 10 is 20, and the path is from x0 to 1, then x1 to 1, x2 to 2, x3 to 1, x3 equal to 3, and then x4 equal to 1. So this is how, using dynamic programming approach, we can easily find out the minimum distance from node 1 to node 10, the minimum path and the path also, the minimum path length and the path also, using dynamic programming approach. So what we have done here, we have divided a larger problem into sub problems, okay. We have divided the problem into stages, and whatever solution we are getting from stage 3, we are using in the next stage, and then whatever we are obtaining from here, we are using the next stage, and the same process we repeat till we get stage 0. So this is basically dynamic programming approach. We divide a larger problem into sub problem or stages, we define stage variables, and then whatever we are obtaining in the previous stage, the solution whatever we are obtaining, we are using that solution in the next stage till we get the last stage, okay. So this is how we can find out the optimal solutions of such problems using dynamic programming approach. In the next lecture, we will solve some more problems based on dynamic programming. So thank you very much.